driven by the force to strive for excellence, determined to reach the frontiers of science and technology, ready to face the challenges posed by the world. We are IIT Dharwad. Good morning, everyone. We welcome the presenters, representatives from MNCs, our director, Professor P. Seshu, Dean, Academic Programs and Student Welfare, Professor S.V. Prabhu, and all our professors. Let's give them a big round of applause. Of Industry Academia link, Dial Mechanical. The theme for today's event is Aerospace and Automotive Industry. The main aim of this program is to provide a platform to our students and faculties of IIT Dharwad to understand, assimilate and be apprised of the developments in emerging technologies. It is also to enable corporates and startups to know more about IIT Dharwad in terms of infrastructure, research activities and industry academia research collaborations. It provides a platform for corporates and startups to showcase their work and even enables connections and networking. Finally, it provides an opportunity for us, for the corporates to look at the talent for collaboration and research and associated activities. I now request the members of the Dial Mechanical 2018 organizing the committee to present bouquets to the panelists. I would request our director, Professor P. Seshu, to address the audience.
Warm welcome to all the representatives from the industry, who some of course are long-time friends, some are new friends from today, and we look forward to a long association with all of you on behalf of the institute. As some of our students have been discussing with you, the institute is new. We are only about 2.5 years old. Our first batch, we are still in their third year. But we are been working on developing industry academia interactions quite aggressively in various areas. We have also been working with other academic and R&D institutes to nurture strong linkages. We have on academia front, we have strong tie-up with IIM Bangalore on agri-economics, because this region is an agricultural belt. So we have had a tie-up with them. We have had an agreement with IIIT Bangalore. We have a tie-up with CSIR institutions and so on. Similarly, we have been having a lot of industry interaction. We have done a dial day for computer science and electrical engineering industries with a specific theme on AI and ML in association with NASSCOM some time back, which was also quite successful in the sense that many industries came forward. We had a day-long discussions, and then the collaborative efforts are taking firmer shape in these intervening months. We could probably be having some projects very soon, and many of our students have been picked up as interns and to work on some projects under the joint guidance of industry people as well as our faculty members. Keeping this perspective in mind, we have organized today's program to bring you to the institute to see where we are, at what stage, and how we are planning our curriculum, how our industry interactions, who are our faculty members and so on. It has not been a great day to arrange perhaps such an interaction. It's a Sunday, following yesterday was a New Year Eve function for this region in Karnataka and Andhra, Maharashtra and so on. So many of our faculty members and probably some of our students are not here this weekend. But we felt that we should go ahead still and organize, bring all of you to the institute and begin the dialogue, because this is only the first step in the dialogue, and we would probably find better occasions, better days to bring you here than on Sundays, pulling you away from your families and so on. So, keeping that in mind, if you look at the way we have been doing our academia, we will probably have a detailed presentation later on over lunch when we sit in the boardroom. You would notice that at that time we have introduced quite a few innovative things on a small scale. I would call them as experiments on academic front. Some of them have clicked, some of them have bombed, which is quite okay with us. For example, we have introduced a course in the very first semester, a compulsory course on appreciation of music and dance for all the students from the last batch. Harvard being the cornerstone of Hindustani classical music, we thought it is an appropriate thing to do. So many of our students have benefited from that, and we are continuing that this year too, also adding theatre to this, because in this region, theatre also is quite active. So these are attempts to keep the creative minds flowing. We also have a course on, compulsory course on design thinking and innovation in the very first year, where experts come and provoke the students to think of problems and to look at a problem in its context, to understand the origin of the problem and the people, clientele who will be served when you solve the problem, and understand their needs, requirements, and hopefully some solutions would emerge. This is also a course that is been introduced in the very first year, which has been highly appreciated by the students. In the first year workshop, as many of you engineers would have done, typically it has been handled by a mechanical engineering faculty, focusing on fabrication techniques. So, what we have done here differently is that this workshop is handled by mechanical, electrical and computer science faculty members, essentially to train the students in a mechatronic systems approach. They get to build remote controlled toys. We want our students to approach engineering as sophisticated toy making. So to introduce them towards that, in the first year workshop has been done in this mechatronics way, so that they are exposed to building these remote controlled systems, and following up on that, most of our courses also have course projects where they need to apply these faculty members. We have about 35, and we have several visiting faculty members here with us from various institutions in India. So through the discussions, it emerged that while we want to pursue the conventional academic R&D, there is also an emphasis to R&D problem identification and solution identification that we have been pursuing. So we have taken up one theme, for example, as precision agriculture, as I mentioned earlier, this region being agriculture based. So precision agriculture turned out to be one of the most logical steps to follow in this institute. We have had strong collaborative discussions with the University of Agricultural Sciences, Harvard, and also some industry partners and academic institutions. Several problems have been specifically identified by discussing with the ultimate end user, who is the farmer. So specifically targeted with the small Indian farmer in mind, we have identified these problems, where our faculty members cutting across chemistry or biosciences departments to computer science and mechanical electrical engineering departments. We have formed teams who can work together with these farmers' body or academia from University of Agricultural Sciences type of institutions to look at holistically a problem and find a solution that will ultimately work in the field. So that has been our approach when we look at outcome-based RI. So we have made some strides in that direction. So that is how we have been shaping up for a 2-year-old institution. I think we are doing quite well. But of course, that is for you to tell us at the end of the day. Our campus is coming up fine in the permanent land that has been given to us, about 530 acres, across the highway that you have come to reach this place. This is our temporary campus. A tour has been arranged for you during the day to see the temporary campus. Permanent campus buildings, probably construction will start after the monsoon. By then we would have awarded the tenders. The Honorable Prime Minister has already laid the foundation stone for the permanent campus. So the construction would begin, I would assume, by August, September, and should take about 2 years to complete the first phase. In the first phase, what we would be getting would be the academic areas, then the hostels, the quarters, laboratories, and so on. Essentially to house about 1,500 students. So that is roughly our target in the first phase 1 that we want to complete in about 2 years. So that is roughly where we are as an institution. Once again, warm welcome to the events of this day, which is to understand each other better. I think our students have been working hard and come up with some questions which are bugging them as to what should a mechanical engineer have learned before getting out of the institution's portals in this 21st century. Because everywhere you look around, you hear only AI and ML, as if nothing else matters. So there is almost an existential crisis for other branches of engineering, I would say. So we look forward to your opinions and advice to us on how we can frame our curriculum, how we can train our students to be ready to contribute to the industry and to pursue their dreams, basically. With these few words, I now hand over to the organizers.
Welcome Dr. Sushil Ramdasi and Mr. Nagesh Raj. It's a round of applause. Dr. Ardhendu Pathak from Airbus.
I'd like to see almost everyone is awake. My name is Ardhendu Pathak, as was just introduced, and I was with Airbus till December. Since I'm no longer with Airbus and I'm on my own, I thought it would be best that I talk about Airbus but not speak on behalf of Airbus. So I'm still in touch with Airbus, but it's better that I don't speak on behalf of Airbus. So I don't have a presentation, but let me give you an overview of first aerospace, a little bit Airbus and then Airbus India and what Airbus has been doing. So Airbus is the largest European manufacturer of defense and aerospace industry. Globally, the aerospace industry is, including defense, more than $2 trillion. So it's a large part of world economy. The number of people who fly has been increasing year on year. Can you guess how many people would have taken a flight last year globally? Just a rough guess. World population is about 6.5 billion. So take a guess. About 3 billion people, not counting the individual flights, took the flight. And the reason is, whenever the economy grows, flying is an aspirational thing. People, when they graduate from lower middle class to middle class, one of the things that they want to do is flight. And as businesses grow, there is increased demand for flights. So what happens is, as the world economy grows, the aerospace industry grows. So the growth of industry is indexed to the world economy, and as you know, world economy is growing, especially in this part of the world. India is already the second largest flight zone. The demand is high and it is growing, despite the bad news that we might have seen recently number of people who are flying is increasing. Just witness the number of flights to Delhi from Bangalore, and you will know that this part is growing. So Airbus has been part of this journey right from the beginning. The genesis of Airbus is in the European companies of all the warring nations in the Second World War. So Germany had Daimler Aerospace, France had Aerospatiale Matra, Spain had CASA, and Britain had BAE Systems. And these were making their own planes. If you go and look up Google, you'll find the planes made by these companies. Some of them are still flying, by the way. But they realized that alone they cannot compete with Boeing. Boeing was a giant and continues to be a giant in this field. So to compete with Boeing and also to reduce the chances of the Third World War between the warring nations, consolidations across the industries happened in Europe, starting with coal to aerospace. And these four companies decided to start working together. And that's the jet course aeroplanes that you must have seen. The other parts which carry the satellites are made by Airbus along with a partner. Along with satellite constellation, the One World constellation, which is coming up, 1,000 small size satellites will be put up very shortly. And then of course there are military planes, A400M and so on, C295, which has been discussed in India as well. Helicopter division makes helicopters, multi-role helicopters, and it is one of the big global companies in helicopter space. And Airbus Commercial makes the commercial planes that you see and must have flown on any of the commercial routes. Do you know what's the newest plane that came from Airbus? Anyone? A350, any other? Well, there is a plane called Beluga. It is not a commercial plane. It is a plane that carries plane. The plane parts have to be carried, and you need a plane bigger than a plane to carry it. And that plane is Beluga. It is not a commercial flight, but it flies between Airbus sites, carrying the entire cylinders, the cabins of different planes. The wings are of course stacked and carried separately. But that's the plane, that is the latest one. If you Google the images, it is a fantastic plane because it can carry the entire body of a A320 inside its belly. So the front side opens up, the belly is slit inside and the front closes, and the pilot sits very high, and the shape is like a whale, and that's why the name. And you're right in a sense, the newest commercial plane is A350, for sure. A350, after nearly 10 years of development, was flown for the first time 3-4 years back. I was lucky enough to be present in Toulouse to witness the first flight of the new plane. And I was surprised to see the emotions that people had. After all, it's an industrial product. 60 of them are made every month. It is like like a giant stapler. You make it in the machines that churn it out. But believe me, in the Toulouse and adjoining areas, there are a lot of retirees of the company. And it was a festive atmosphere. People had lined up the streets from where they could get the view of the flight. On the terraces, rooftops, people carrying flags and so on. And after it successfully took off and landed, I have seen people crying, grown-up people crying actually, with tears in their eyes, the tears of joy, of course. And the reason is, if you're lucky, as an aerospace engineer, you're lucky to see 1 or 1.5 new plane being developed in your entire career, because the cycle time is about 15 years. If you get a go ahead from your board today to develop a new plane, 15 years later, the plane would be flying if everything goes on time. So in your lifetime as an engineer, you would see about 1.5 developments. So it's a very emotional situation for the first flight. It is also first time that the plane takes off from the ground. And they say in Airbus that till it in aerospace, have you thought next to pilot and the plane is flown by a joystick, a computer game-like joystick that flies the plane. And this sophistication was brought in mid-80s by Airbus, and takers are here. The question on your minds must be what kind of people Airbus hires in India. So every year there is a hiring. Of course, freshers are hired from IITs, and they are hired in all disciplines, not only aerospace but mechanical, electrical, electronics, and computer science. And this happens every year. You can look it up on the website, and you will know the hiring is on. A large volume of hiring also happens in the supply chain of Airbus, which is GE and Rolls-Royce. Companies like Sopra Steria and so on. So large supply chain of Airbus and aerospace in general is also developing very rapidly in India. Big companies like Tata's, and I'm sure Sunil will talk to it a little later. Tata's, L&T, Mahindras are all in aerospace, and aerospace doesn't mean that they are hiring only aeronautical engineers. They are hiring across the disciplines, because plane is a system of systems, essentially. All disciplines are represented. So if you are interested in a career in aerospace, irrespective of your branch, I'm myself a mechanical engineer by training. Aerospace is a good domain to look for. So that's a brief introduction of Airbus. And if there are any questions, I can always take it later. Thank you very much.
About mobility engineering construct.
Good morning. My name is Kathy, and I am a director at Mobility Engineering Consortium. We are an event management platform that provides students with skills and connects them with industry. So pretty much we create projects. They not only build on their engineering skills, they also build on team management skills and communication and all the soft skills that are required for you to go into industry. So that's our logo, and the reason how we came about that is we try to cover all 4 areas of mobility, being on land, water, air, and space. I see that my font has changed. At this point, we started in 2016. We launched then, and right now we are connected to over 3,000 students all over India. We hope to grow further and as we move on. Right now we have our projects in land, and we're eventually going on to space. We not only connect with students, we connect with industry partners, because all our projects look at what the students have innovated and also question them on their engineering basics, figuring out how they came to the solution, what problem did they solve and what solution did they come up to. So change. So that's you, imagine that's you and that's your brain working over there. And so our competition takes you, the individual. It poses a challenge. Oh, this is going to be so hard. And it requires you to put in your analytical thinking skills. This is why you all are engineers, right? We have to use analytical thinking to put towards problems out there. And so you get, it's going to be difficult. So you come up with a few set of skills, which is problem solving, CAD modeling. You learn manufacturing, leadership management, and budgeting, funding, and as it goes down, marketing, and so much more. So our company, we not only look at a competition, we not only stage the competition, we involve training, we provide resources as well, and these resources are not just online resources. We have mentorship and conference workshops throughout the year. We have you directly working with the individuals, and we also connect you with industry after that. One of our major projects is Formula Bharat. If many of you have heard about it, it's an engineering competition in which students have to build a life-size formula-style vehicle, and we run right now both the combustion and the electric versions of it. Currently, we register close to 80 teams in total from all over India. So you have to literally build the entire vehicle from scratch, and it's not a racing event as much. You do have the dynamic testing portion, but you have industry partners questioning on what design goals you had. How did you come up with this vehicle? What are the issues that you were facing, and what are the team management issues you were facing as well? So here are a few photos from the 2019 event that just finished in January. We've opened registrations for 2020 as well. So that's IIT Kharagpur team cart. This is GTU Motorsports. For those who have never been to Formula Bharat, that is one of our tests where you're supposed to tilt the 60 degrees, checks for liquids, and also a center of gravity. That one is a stallion from Sihagarh. Sihagarh, I forget the full name, but College of Engineering in Pune. They're also one of the really good teams in India. And that is Kratos Racing. They used to be a combustion team, and in a year they switched to electric, and they finished all the events, which is a first in India and a first in my journey for a first year electric car. And this was our first electric event, so it was a huge deal. So that's Team Kratos from electric. I do have video, but I shall play it later on today when you all are more awake. So that is Formula Bharat. We are now going into, before we go into that, as I mentioned, we do host resources and workshops. So we do have the Formula Bharat Academy, which connects you with resources, with judges and our leaders, our leads who help support the event. This was in Pune, that 2 years ago that we had a 200% capacity at. And last year we went to 4 different cities. We went Pune, we went Chennai, Bhubaneswar, and in Delhi. So we always get complaints that we don't cover the east, so we went to the east this time. And then we have the FS Electric Vehicle Concept Challenge. And the purpose of that is, before you decide that, hey, electric sounds cool, let's go and build an electric car, we give you a platform where you can come and research and plan how long it would take for you to build an electric vehicle, what are the obstacles that you'll have to face to get components, because a lot of electric parts or components are not available in India yet, that you have to get them from out. And so understanding the import-export times and working with those things. So we have this, and we're working with Aether Energy in Bangalore, which hosts this event, and this would be our 3rd event happening in July this year. So further on, we are expanding from Formula, and we are going into a new challenge in November called the Astrover Challenge, where students are required to build a human-powered vehicle that would traverse over simulated terrain. It is somewhat like that, but doesn't necessarily have to look like that. And it would be one of its kind in India, which we're starting in November and planning to host in Mumbai. So if anyone's interested, you can look up our website. In next week it will launch. And yes, you are required to build pretty much everything from scratch, including your wheels and tires, and to imagine that you are on a simulated terrain, and ensure that, and you will have a specific set of obstacles, including tasks as in collecting solid and liquid samples as you go along the system. And yes, so I am done. If you guys have any examples of projects that you would like to be involved in, please meet me after, and I'll be more than happy to talk to you about it. Thank you.
Of interesting projects. Now I would like to invite Mr. Mehak Modi from Ather Energy.
I'm Mehak, and I am from I'm from Ather Energy. I joined Ather Energy 4 years ago to design the chassis of the vehicle you will soon see. Today I essentially help set up manufacturing and supply chain at Ather, which you'll hear about again. Ather is an electric vehicle OEM based out of Bangalore. This is something that we've been working on for 6 years. The company has been existed for 6 years. And earlier this year, last year, 2018 June, we launched our first vehicles, which are the 340 and the Ather 450, which you see in the picture there. We're looking to set up a sustainable electric vehicle ecosystem in India. So it's not only the electric vehicles that are not only Ather vehicles, but any electric vehicle that comes to the port. We today offer free charging to any electric vehicle who come to these ports. Today, these are in Bangalore only, but in a couple of months we should be in Chennai, and by the end of this year we will be in 4 cities. Ather started in 2013 out of IIT Madras. These were fresh graduates. Imagine most of you guys stepped out of university and initially thought about creating a battery company and a product on which the battery should go on to, and hence decided to move fully into the electric vehicle space. We have a fairly large, we are a 500 plus people company now, so we've grown quite a lot, specifically in the last 2 to 3 years. We have our own R&D center which has 350 plus engineers, our own manufacturing facility which you can see there, right? This is an entire assembly line that we set up from scratch. Like 2 years ago, this was empty land, and we assemble all our vehicles ourselves, and we manufacture the battery in India. We are the only company who manufactures lithium-ion batteries in India at our scale. And along the way, we've obviously built 52 prototypes, which means that we've iterated through and through multiple types of vehicles before we ended up at the vehicle that we shipped. We looked at vehicles with lower speed and lower range to very high speed, very high range, and settled at what we have today. This is the picture of the Ather 450 and the 340. They both look the same. They have small differences in spec. This is an electric vehicle that matches most petrol scooters for top speed and ride and handling performance. While acceleration, because we're electric, comes naturally, and we're ahead of the curve through most of this thing. So our pitch is essentially electric vehicles are not a compromise. Electric vehicles are the future, and this is essentially us saying we match spec to spec. Just to give you some idea, our lithium-ion batteries are designed and manufactured in Bangalore. Lightweight hybrid aluminum chassis, which we made from scratch over the last 4 years. We have a patented touchscreen dashboard and vehicle control unit. So we're the first two-wheeler company to have a touchscreen dashboard that is weatherproof, can be seen in bright sunlight and late in the night. And finally, the private and public infrastructure. So that's fast and slow charging. I won't go too much into the specs, but what we are generally proud of is our quickest acceleration for any two-wheeler from 0 to 40. The largest in any scooter storage space, and 1 kilometer per minute fast charging. These are things that, again, fairly young engineers have developed from scratch within our R&D center in a fairly dramatic pace. Here you can see the 7-inch touchscreen we had, again designed in-house, and it's like Professor Sheshu rightly put it, we started this off as a sophisticated toy project that has scaled, and finally reached in a product that is viable to the market. Just a glimpse of our charging infrastructure. Fast charger, 2.5 kilowatt charger is the fastest electric scooter charger in India. Again, developed completely in-house by the engineering team at Ather. And this final bit about the charging infrastructure network. These are how our pods look like. They are all over Bangalore. You are never more than 3 kilometers away from one. And this is what we intend to do before going to every city that we launch in. Something that you would be interested in. We have power electronics, vehicle engineering, which is essentially very core mechanical engineering focus. Embedded electronics, battery, which is a huge cross-functional effort between power electronics, embedded electronics, and mechanical engineering. Large portions of thermal management, lots of interesting materials used, and finally software, which is just an underappreciated thing. You can't do any AI and machine learning unless you have data. We have 63 sensors on the scooter that give different sorts of data which enable them to do a lot of work and directly feedback into the mechanical systems that we have. The list you see there are the things that we build in-house. The average age of our engineering team is about 29. So it's a fairly young team. A lot of them fresh graduates straight out of engineering who believe that they can build products and build products very quickly. And that is essentially what Ather is about. This is a few glimpses of our workplace and the internals of our chassis. What you will notice is that we spend a lot on R&D to make sure that we have the technological advantage in the EV space in India. We believe right now we have the strongest EV design team in India today. Just going ahead over the years, we're going to look at launching EV charging points in 30 cities. The Ather 450, which is, production is ramping up very quickly. By the end of the year, we should be able to get to a capacity of producing 45 to 55,000 scooters every year. And finally, obviously, we have that really large R&D team who are now primarily focused on building more EV products out there, faster chargers, faster scooters, potentially bikes and other things. So that is a brief about Ather. Again, more than happy to answer questions at a later stage. Thank you for having me here.
Now I would like to request Mr. Deepak Daloti from Servo Controls Aerospace to present.
It's an amazing conglomeration of academicians, the industries, and really a great place to be here. I'm really delighted to be here. Thanks for the IIT Dharwad. We are just 70 kilometers from here at Belgaum, and it's really what then a student from an engineering college, and that too from an IIT, can take from this sort of a meeting is actually an the next one here. Actually, in an engineering college, when I was in which is the next one? This one. Yeah, actually my journey started from an engineering college, from KL Engineering College. Like I was a student like you, and I did a great project in the final year engineering called Complete Design and Drafting of Hydraulic Cylinders way back in 1991. And there was only one computer in our entire KL Engineering with math coprocessor. And that time I was doing a project on a Lisp, artificial intelligence language. And when I used to keep it for write a code in Lisp, like AutoCAD now you see Auto Lisp, it used to take 2 days to compile one program. And my head of department, computer science, Mr. Pungin, he said that Deepak, this one you can't do, you have to change your project. And Dr. Babladi, who was the principal that time, he said, no, we'll give him one math processor. But only he can come early morning 3 o'clock to 6 o'clock to the college and do this project, put it for compilation. Rest of the time the math processor will work for compilation, and rest of the time the MTech students will use the computer for that. What I mean to say is every institute has a lot of limitation, like a clearly that time a very rich institute, but still they couldn't afford that sort of computer way back in 91. And till whatever I did the project in my final year engineering, still I am on the same field till date. And we took that technology to use in our Mars mission, Mars orbiter mission. Okay. So what I mean to say is an engineer with a passion can, like IIT, and just I saw the Aether, how they developed the scooter, this I want to ignite your minds. So servo controls is basically into aerospace, defense, then steel rolling mills, whatever all the applications you see here, we do all that. And today servo controls is a very, what you can say, a very closing the loop is a very secret technology in the world. Only few companies have mastered, and we have an ITAR from America and France and Japan. They don't give this technology anywhere else. Only like a company like, unfortunately, American said you can't put servo control company in India because it's a very secret technology. And Kalam Saab's dream was there that without this he cannot build neither a satellite from VSSC to put it into the orbit nor into any missile. So after the Pokhran test, when I was working in America, he called me and told there was embargo, and we came and started in literally a house garage. And today it's really a thrilling journey from home garage to a Mars orbit. So what in servo controls we do is we close the loop. So what is servo controls? Like I am standing here, it is closing the loop. It involves software, hardware, like electrical vehicle, you see the drive, any actuation, and then maybe linear or rotary. Then it closes the loop with any sensor like encoder or position sensor, LVDT, and closes it. And in hydraulics or in mechanical, it closes with the one valve, actuator, and closed loop. So this is the fundamental technology which is having in each and every industry. Take it from ag equipment to the satellite. Closing, like I am standing, my brain is giving a signal to the heart where to pump, what pressure to be maintained in the body, and accordingly I stand. And the sensors, the ear lobes, where I get the feedback, and I stand, I sleep. So closing the loop is servo controls. So using this technology, we have built a lot of what you can say, the applications basically. So when I was called back in India in 2002 to work on some of the secret Indian projects, there I all that sort of stuff. And then we became we developed a very specialized sensor to put the satellite into Mars orbit. So this is how we became a partner with ISRO and all that. So that's what I want to ignite. So Kalam Sahab always used to tell, whenever you get a chance to go and talk to the students, go and do that. Don't say no, because ignite their minds, brains. One day they will be an asset to the nation. So not only that, second very important thing is about the, what I can say is the air data products. This is one of the most important product, which is totally like, now you are all hearing about the 737 MAX collapse. So I am developing this for HAL from last 7 years, and how the students, faculty can help us to come out with some of the newer ideas. So these are the things what we do in servo controls. We are the very unique company in India where we are one of its kind, and a lot of programs in India depend on us. Then build the 6 of motion simulators, then actuators, valves, which are called the fundamental building blocks for servo controls. Like when the Taj was hit, there was a dream by Ratan Tata ji that I should have a ship destroyer drone which can go more than the speed of the ship, that is 30 nautical miles. This can go up to 45 to 50. So he tied up with IAI. He called us in Tata Sons and called all the Tata heads over there and signed an agreement with us to develop the actuators for this killer drone, and it is autonomous with self-vehicle. Almost 250 more are installed. If you want to see the picture, I'll show you later. So how we became part of it. From a team from Belgaum, they built it and successfully built more than thousands of actuation systems and delivered a separate line for that. Then we are working on a ship. There is the aircraft carrier, also with a lot of Russians, and the submarines that we are going to do, how the technology is used there and what are all the products we are doing over there. And a lot of DRDO people come to us to develop the products to us. From almost all DRDO labs we work, like R&D University Pune, the research center in Imarat from Hyderabad, then DRDL, so many, more than 24 institutes from even the wafer companies and all. And they come up with a product to us. Every scientist is at Belgaum, one or the other, twice in a week. And he said, you develop this program, you develop this product and all. We pull out from VTU now. We have tied up with the Vishweshwara Technical University there. We have 200 plus engineering colleges there. So a lot of IITians also come there. A lot of foreign students come, and we give them a project. Then we tell them, I need this much is the output. The biggest problem with the student is they are not there for a long time. So we work with the faculty, and faculty becomes our first point of contact. And a lot of these are very secret things, so we have to maintain a lot of IP and secrecy and all. And reverse engineering also from Russians and basically from French, because as Mr. Patak Saab said, in Toulouse and those areas, those people where I also lived in Paris, there is a place called Châteaudoux, just 1 hour drive from Paris. It was called the aerospace child part hub of the whole world. Today, if you go there, it is a ghost town. Hardly 30 houses are there. Because all the oldies have died and new generation doesn't want to come in the real core engineering. And all that manufacturing is coming back to India. And we don't have the people. So there is a big opportunity there to manufacture a lot of stuffs. Second very important stream that we do is nanotechnology, where I will display you later some of the great nano motors, like how they are used. Like everybody is in the cell phone, you just zoom it and zoom in. There is a very teeny motor is there, and it's used on a piezoelectric technology, which is immune from EMI and EMC. So how that is there? So we are working with Institute of Science, Nanotechnology, Dr. Prahlad and all that people, so that we can do it in India. At present, we source them from Israel. So these are some of the, and they are used in infrared cameras, low Earth orbit products and all. So there is a lot of work to be done. Even if you work for next 100 years in India, developing all these products, there is no dearth of, we need so many bright engineers that they sit to understand. Technology is there in the Google, but how to convert that Google knowledge or any knowledge into a product and sellable product economically is the biggest challenge. So this is for our Ariane submarines. We were totally dependent on Russians. We indigenized a lot of stuff. The Dr. Saraswat, who was the great scientific advisor at that time, and today with Satish Reddy and all, we work, indigenize a lot of these actuators for submarines. They are very special raw material and AB2PKM. And one of the things I want to share you friends, and over here, each submarine nuclear cost around 70,000 crores of rupees. Tata's and L&T's, Tata TCS is doing all the electronics, L&T is doing all the mechanical stuff. They are the prime contractors. We are this tier 2. I was told when the commander, now as I'm talking, till yesterday night 2 o'clock there was a testing going on. So every day the country is paying 10 crore interest. Only 10 crore interest. They are not in the water. They are still at the shore at Vizag. And Russians have raised their hand. We have to clear the rest of the stuff by ourselves. and a lot of engineering know-how is required to finish that. So I can discuss with you individually how you IIT can chip in and help us to do a lot of work over there. And some of the landing gears that we do for some of the very specialized program over here. Then like all these customers, we work with IIRFIL and all the people over here. So guys, this is a great opportunity in servo controls. It covers almost all fields of this thing. And secondly, we are also into the nano satellite lab. We are setting up at NIT Surathkal and so many other engineering colleges. So we will discuss about that also. So what I mean to say is, you have to focus on one thing and make it happen. So be a jack of all, but master of one, not none. Thank you very much.
Now I would like to Nagesh Hedge from Aquas Belgaum. Please give a round of applause.
Pioneers, collaborators, a global ecosystem that provides core precision engineering and manufacturing capabilities, driven by innovation and quality consciousness. We rely on our ecosystems of efficiency to drive change, deliver more value to the customers. We are ACUS, a global manufacturing company with a series of integrated, co-located facilities that support the entire manufacturing value streams and one of the fastest growing precision engineering companies. Our name, which means equals, reaffirms our belief in the value of collaboration in the intensely dynamic and demanding domain of precision manufacturing. We specialize in precision machining, sheet metal fabrication, closed die forging, aerostructure assemblies, and special processing for aerospace and industrials. Seeded as an idea way back in 1997, when Aravind Melagari co-founded Quest Global, ACUS has come a long way. Then an engineering services provider, his vision has today transformed into an efficient network of trusted global partners who collaborate and work towards a unified goal.
This manufacturing ecosystem based here in India, but extending to sites in Europe and North America, allows ACUS to provide speed of execution, reliable manufacturing solutions, and ultimately lasting value for our customers.
We have gained a strong foothold in the booming aerospace domain, and our operations are carried out collaboratively through facilities located in India, USA, and France. ACUS facilities are equipped with state-of-the-art machines and follow robust quality systems and processes approved by major OEMs and global aerospace companies.
We'll continue to provide innovative manufacturing solutions for our customers in every market we serve.
We are driven by ecosystems of efficiency, propelled by a passion for precision and an unflinching desire to build symbiotic relationships with global majors. How do we achieve this? By investing in developing capabilities and technology upgradation to promote self-reliance and building ecosystems of efficiency. ACUS operates several manufacturing facilities in India, US, and Europe, and actively pursues joint venture opportunities with global majors to broaden its capabilities.
Our partnership networks are forged with care. We believe in creating global partnerships with recognized industry leaders that drive our ecosystem.
Our partnership with Aubert and Duval SA of France led to the conception of Squad Forging India. Squad specializes in medium-sized aerostructural parts, landing gear, and braking system components in aluminum, steel, titanium, and nickel-based alloys. This greenfield closed die forging facility is set up in 20,000 square meters with 2 separate forging lines. one comprising of a 10,000-ton hydraulic press and a 1,200-ton screw press. Comprehensive, robust, and truly state-of-the-art. A joint venture between ACAS and Saab AB of Sweden. Aerostructures Assemblies India Private Limited, AAI, specializes in build-to-print aerostructure assemblies for commercial and defense aircraft for emerging markets. AAI is ideally positioned to harness defense offset opportunities in the Indian market. Aerospace Processing India, API, is a joint venture between ACAS and Magellan Aerospace of Canada. The company gained prominence by providing aerospace surface treatments that were previously not readily available in India. The first independent facility to be approved by Airbus and Boeing in India. The fully integrated, scalable facility, operational since 2009, has approvals from other OEMs and Tier 1s, making it a unique value proposition. The new expansion will accommodate additional capacity and capabilities, supporting water-based paint, solid film lubricant, sulfuric acid anodizing, zinc nickel plating, and additional processes under development. Deep Hole Solutions India Private Limited is a joint venture between ACAS and Pressy Hole Machine Tools. This joint venture aims to leverage low-cost manufacturing advantages while delivering to global companies, which are keen to source precision machining components in emerging economies like India.
We have built a rich and robust network and ecosystem, and delivering on our promises has forged us into the preferred partner for our chosen customers.
We hold the distinction of possessing the highest capacity in the Asia-Pacific region, with an aim to quadruple our current capabilities within 4 years, and continue charting an upward growth trajectory, moving from strength to strength. We combine the benefits of specialized manufacturing centers in Europe and the US to enable close customer collaboration with a global ecosystem in Belagavi, India, to provide vertically integrated manufacturing capabilities. A part of aerospace facility is located in Paris, Texas. We have 4 facilities in France, in Cholet, Delage, Besançon, and Aubigny.
Guided by our core values of transparency, trust and respect, we are building a global aerospace manufacturing ecosystem to deliver vertically integrated solutions to our customers.
Our customers include global industry leaders, ACAS, Ecosystems of Efficiency.
Okay, so I have 4 minutes video. So watching video, it helps me to go through presentation quickly. Okay. So these are our core DNA, which shows us accountable, vision, and values. So accountable is the vision, and values. So ACAS, key focus with core values. So these are our aerospace leadership team. So we can see Arvind Zamanigiri, who is the founder, chairman, and CEO of ACAS, and so global leaders. So this is the ecosystem what we built in Belagavi. So this is around 250 plus acres. So close to Belagavi, 30 kilometers from Belagavi. So on highway towards Pune. We have 24 units operational now. Okay. So this is the ecosystem what we have. So this you can see we have raw material, forging, then precision machining, surface treatment, assembly, engineering service. So why we call ecosystem is so customer what he needs. So complete solution under one umbrella. So this is the ecosystem what we built, and it is a success story now. Because capabilities support global customer base. So we have forging facility, precision machining, sheet metal, surface treatment, engine components, and aerostructure assemblies. Okay. So we are serving to all major OEMs, including Airbus, Boeing. So major all other customers you can see here: Spirit, Honeywell, Premium Aerotech, Collins Aerospace, Safran, Dassault, Eaton, and SAM. So this is about JVs. So we have surface treatment. So tied up with Magellan Aerospace, and forging heat treatment with Avram Duval, and assemblies with Saab Aerospace. Okay. So this gives joint venture gives us edge to transfer technology quickly and get into industrialization and production. Okay. Because global delivery sites, so you can see we have site in Belgavi, so we have France in Aubigny, Besançon and Cholet, and also in Paris, Texas. So not only in India we have ecosystem, we are close to our customers. So Airbus and Boeing, they operate from US and Europe. So we have our manufacturing facility close to our customers. This is the aerospace product portfolio. So you can see aero system components, actuation components, basically high precision, very high complex components, as well as aerostructure components, and engine components, landing gear. If you name any commercial aircraft, one or the other part from makers, fitted there. Okay. So that's how our product portfolio is spread across. And ECAS SEC unit holders and customers. So ECAS is a second current occupants in ECAS SEC. We have Quest, so our sister concern. So they are engineering service company. So UFI and ECAS, Sandvik. So these are all the occupants in ECAS SEC Belgavi. So ECAS ecosystem at work. So you can see here, this is the one best example. So where ECAS ecosystem is working well. So from raw material, so we have raw material billets. So then within 2 weeks squared, so forged, and then pre-machined at ECAS precision machining unit. And then within a week again, so heat treatment is done at squared. And so after heat treatment, API, surface treatment, etching and NDT, so carried out etching and NDT, and then within a week, so finished machining. So this is the total approximate cycle time for a batch of 90 parts is with zero transfer time. So this is the kind of ecosystem. So best example from raw material to finished product, what we can deliver to our customers. You can see recent awards and recognition from Airbus. So we are awarded with Airbus Innovation Award 2016, Airbus Detail Part Partner Award, so D2P again from Airbus, and Airbus Supply Chain and Quality Improvement Plan Script Award in 2018. So we are closely associated with Airbus. So more than 10 years we are directly delivering to Airbus. So they recognized us and. So that's it. So you can see from start, so 2006 to 2018-19, where we are, how rapidly we are growing. So year on year we are growing 30 to 40%. So that is the growth what we are at. You can see major milestones here. So each year, so one of the other key milestones what we achieve. Okay. Thank you.
Next, I would request Mr. Sachin to come and speak about Fiat Chrysler Automobiles.
See, I am here because one of my classmates, Mr. Dheeraj, Professor Dheeraj, is here in IIT Dharwad. And when I got invitation from him I thought of that this is a good dais to share our views with the students, because some years ago I was also student, and see, I passed out in 97 in mechanical engineering, and that time those were the days when there were no internet facilities. I first time experienced email exchange in 1999, and before that we just used to reach the companies with the hard copies of the resume. See, even though today if I am saying to my son, you have to become an engineer or doctor or architect, so he can understand what the doctor is doing because they can see, and what architect is doing. But they cannot imagine what engineers are doing. Okay, they can only see there are some automobile service garages and all, whatever we are visiting. They cannot really visit the company and see how engineers are working. So when I passed out in 1997, we were also not too much aware how the industry works and what is the profile of the engineer. We visited in our Bachelor of Engineering some of the industries like NTPC, and then some hydraulic power plants and all. That was the exposure given by our colleges. So after my graduation, I joined one of the suppliers, sheet metal industry, who was supplying to Mahindras. And then I used to interact with Mahindras in Nasik. And there I came to know such kind of R&Ds are there, and such kind of how they build the vehicle, how they have teams and all. And that time I had a dream to become a designer. Okay, designer for the engine parts or mechanical parts, because I used to work with designers to develop their parts. And that is how I went for post-graduation in VJTI Bombay, and myself and Dheeraj were there. And after passing out from VJTI, I joined Mahindras in Mumbai as a postgraduate trainee. And from there, our career started. I worked in engine design in starting phase, and I used to know what exactly the difference between academic and the practical things. Because in academic we learned the crankshaft design, and when we started crankshaft design actually in Mahindra, then we used to know this is a vast field. It is not just academic. To step down with the 10 steps that you start with this and end with this. This is crankshaft overall. It's not like that, because you have to deal with a lot of literature which is developed by most of the engine consulting agencies worldwide, and then you can really understand within year or two how to design one engine part. So like this, we were part of engine R&D in Mahindra. But in those days, we were aware of R&D things and testing developments, and how to deliver the things to for the project. But once I spent some years, now I am here in automotive industry from last 18 years. So after Mahindras, I was there with General Motors, then Eicher Motors, and now in Fiat Chrysler. So used to understand how the business runs actually, why companies are running, how they do the business, how they develop their business case, how they do the project management, how they leverage their global R&Ds to develop products in India. And in student age, whatever were the questions like why we cannot localize the car in India, why they are not starting R&D center in India. So now we have all the answers, because that's not easy. It's everything based on financials. So this is how I would like to summarize my career, and I believe that if students have interactions with industry in their students' career only, they can able to see how practically it is happening. So that is how I summarize the thing. Thanks for inviting me.
I'd like to invite Mr. Dr. Sushil Ramdasi from ARI.
I don't have any formal presentation, so I'll be talking in 10 minutes because organizers, they have requested me to finish in 10 minutes. Okay? No problem. First of all, I would like to thank IIT Dharwad for arranging such a wonderful platform and inviting the galaxy of all the real experts who are sitting over here. I think we have listened almost 5 presentations from the morning, out of which 3 are focused on aerospace, which is the really most complex one. Okay? Now let's move to another level of complexity. Slightly one step down, I can say, it's automotive engineering. Okay? So myself, Sushil Ramdasi, Deputy Director, working in ARI for last 25 years, and right now taking care of a vertical called as the Engineer Transmission Design Center at part-1 Engineering. Okay. This is just brief introduction of mine. I would like now to focus more on my company, ARI, that is Automotive Research Association of India. Okay? So ARI, I think most of the people who are from the industry, they are mostly aware of it.